go back to our... So the half-life, by definition, is the time required for the level of radioactivity to fall to 1/2 of its value. In the examples that we just saw, we saw a half-life of 50 seconds and a half-life of 100 seconds. In both cases, the graph looked like this, which is what we call first-order rate kinetics, but the time scale was different. And in this particular example of plutonium-239, the half-life is the amount of time it takes for, they're saying this is 100% of the original sample, the time it takes to fall to half the original amount right here, if you go down, is 24,000 years, 24,110 years. So that means if you start with, say, 100 atoms, in 24,110 years, you'll end up with 50 atoms. And then the next half-life would be another 24,110 years. That would get you up to 48,220 years before you have, again, half remaining. So 1/2 times 1/2 is 1/4. And then half of that again would be 1/2 times 1/4 would be 1/8 remaining, about 12.5%, all the way out at 72,000 years. So you can see that the curve looks the same, but the time scale is different, and the rates are given in most widely expressed in terms of half-lives. So half-life, the time required for the level of radioactivity to fall to 1/2 of its value. And so here's just some different isotopes so you can get a feel for the wide variety of half-lives. So for example, uranium-238, the one that's found in the soil, the half-life is 4.5 times 10 to the 9th years. Okay, that's 4.5 billion years for half of the original sample to decay. Potassium-40, 1.3 times 10 to the 9th years. That's why we have radioactive potassium isotopes still mixed in with a regular sample of potassium. Whereas polonium-214 has a half-life of only 0.000016 seconds, so that doesn't stay around for very long. So this is how we could explain, even though we have in nature radioactive isotopes, we know they're undergoing spontaneous radioactive decay. If that's the case, you may ask yourself, why do we have any of those isotopes remaining? The reason why is because the decay rate in some cases is very, very slow. Okay? And in some cases, it's very, very fast.